Good evening, everyone, and I thank Professor Wabi for giving this opportunity for me to present this topic on ocean wave energy for the sustainable future. And today's current generation depends a lot on fossil energy, which is not a renewable energy, and because of fossil energy, the phenomena such as global warming is happening and causing some of the organisms and some of the plants to be extinct due to the rising sea levels, and even the land is getting decreased because of the increase of ocean water. uh, Now I'll take you to what is ocean wave energy. Everyone talks about using renewable energy, and when coming to the point of implementation, we find it difficult, and we just go back to the non-renewable energy, like just like the fossil fuels. And in the case of ocean wave energy, uh, it is a renewable energy, and when we use it, it contributes a lot when compared to other traditional renewable energies such as solar energy, and hydro energy and wind energy. uh, and my presentation will first be focused on comparison of the renewable energies, and I mean the renewable energies are like solar, wind, and general hydropower energy. And then it goes through the basics of ocean wave energy, and then it gives the statistics of what ocean wave energy can provide us for the sustainable future. And then I'll be explaining, and then Rishang probably will be taking you through the advantages of ocean wave energy and where it can be produced more economically. Next slide. Renewable energy source. Ocean energy, wave energy is when we use it, actually we can actually have much more amount of renewable energy when compared to the wind and solar system. Traditionally, the fossil fuels, 85% of the fuel generated is from the fossil fuels in today's world, and 8% of it is from nuclear, and 4% is from hydro energy. When we look into the renewable energies, 44% is from biomass, 48% is from hydro energy, and 8% is from solar, wind, and geothermal energy. So I guess it's about 15%. 15% is a lot less when compared to the non-renewable energy. So we have to focus on improving our renewable energies so that we can lead to a sustainable planet, where we can have everyone without much defects in it. Yes, next slide. So it can when we produce ocean wave energy, we can have a potential of 2000 terawatt hour per year energy, which is equal to 22,400 megawatts per year. That's a lot when compared to wind energy and wind, solar, and hydropower energy. And next slide. uh, the renewable so this research is actually being carried out in northwest part of California, and it can the research plant can actually produce an energy of 30 kilowatt per meter wave. And the solar energy, while if you install the solar plates of an area for about meter square, it can just produce 300 watts, and which is much more expensive to operate, and it is not possible to generate electricity at every time. And when you compare wind energy, it produces 800 watts per meter square of area when installed. But even this is a lot more costlier when compared to the ocean wave energy. What happens in the ocean wave energy is there are some sophisticated turbines inserted in the deep ocean beds, and the waves and tidal energy are converted into mechanical energy. Then the mechanical energy is converted to whatever, generally it is converted to electricity, so that we can use our modern gadgets and everything. And Rishang will continue from here.
Yes. Thank you, Vinith, and thank you, Dr. Robbie, for giving such an opportunity. And to generate such energy, such oceanic energy, we need few devices. So We have three different type of devices here. So first one is the channel system that funnel waste in reservoir. The second one is the float systems. Probably that might be a few buoys and all, uh, and which drive the hydraulic pumps and all. And third one is the oscillating water column systems that just compress air and throw it and push it down to the generators, which rotate turbine of the generator to produce energy. That's what the mechanical energy will be produced, and from that, which activates the generator and all to produce electricity. Next slide. And what is the current technological status of the wave energy right now? It's today. It's probably like a wind energy, how it would be in few years back, like 1974 and all. So from these days, many new devices were being invented to produce such oceanic energy, and from different types of devices were invented. Few were in testing stage right now, and few are in developing stage right now. And since 1855, there were 1,000 patents on these devices to produce oceanic wave energy. Some are already tested in the field. So next slide. And this is what the locations of ocean wave energy devices. Just go to next slide. So these are the power. You can have all these points where located there. So from those points, this ocean wave energy has been generated. See these points, like you have these areas where about 60 kilowatt hour per minute such energy is being produced back. So different maybe these energies generated maybe with floating or completely submerged devices, or few offshore and onshore devices which the waves hits, and maybe the deep sea oceans. So once you can find a graph. Can you use this? You can find a graph with which the cost estimated for the oceanic energy. Once we consider the ocean depth on one part and the cost estimated per generating the kilowatt hour energy. So as depth of the ocean increases, the cost of the generating the power decreases slightly. The starting for 10 meters or somewhat. After again, the cost of the cost for generating the power also again increases for that. So the graph will be in such a way, like for depth here again decreases till 10 meters. Again it increases from here. So as the depth increases, the cost for generating the oceanic wave energy increases, as majority of these devices right now depends on the tidal waves to generate this energy. So next and next. So what about the funding of for generating such energy? There is limited research going on these devices when compared to research on other types of energies. So the European Union funds ocean wave energy since 1992 with a total euros of 9.5 million for 9 years, and just these are invested by both public and private sectors. It's investment cost of almost 820 billion euros. And next, from here, my friend, my groupmate Sanit Mineni, he's not here right now. He has made a video regarding that. And Vinit, could you please play that? He'll be explaining you on his part.
Good evening, everyone. This is Sanit. I want to say thanks to Professor Wabi for giving this opportunity. Today I'm going to explain the benefits of ocean wave energy as well as the needs in research and development of ocean wave energy devices. Coming to the benefits of ocean wave energy are they can reduce the dependence on a specific source. These are the energy security for US. They can generate new business development in a local geographic region. They can provide money coastal locations within energy. In remote areas such as islands, wave energy is an attractive energy because of high energy import costs. Coming to the impact of the environment with the benefits of ocean wave energy are these are the less pollution free and these are the less infrastructure as well as less space. Coming to the needs in research and development of ocean wave energy devices are these are the cost reduction, efficiency and reliability improvements. These are the identification of the sites, better understanding of the impacts of marine life and shoreline, weather effects over the life of facility and the ability to survive in the marine environment. For example, hurricanes. Therefore, more research and development money is needed to make ocean wave energy competitive. The remaining part will be continued by Rishank and Vinit. Thank you.
This was Sanit. Uh, so uh, he was back. He was explaining about the benefits of the oceanic energy. So, what are the benefits of ocean wave energy? So, these are available every day, at every time, at every instant of time. So, waves are constant. So, every time we'll be having these few. So, what are buoys? Buoys are few devices which float on the water, from where we can. These are used to get the information from the oceans, like temperature from the water, and so from those buoys we can constantly monitor the oceanic waves, and also from that we can generate good amount of energy and all. Next slide. These can reduce the dependencies on the specific source, energy security for US, new business development in geographic regions, can provide coastal regions with a lot of energy, and in remote areas like islands and many other things where you can't set up a hydraulic plant and all, you can set up these low cost oceanic wave devices to produce energy, which reduce your cost of generation. Next. And this is pollution free when compared to your energy, your hydraulic, those things, and thermal. Thermal is more for pollution. These are much lesser polluted ones, and lesser infrastructure. You don't want to carry your coal from one place to another. These are freely available at every time and on every day, and less virtual obstructive than wind devices and all, and very quieter. You don't get more sound from these devices. And why we should use these devices, and why we should use such oceanic energy? Because they are very cost efficient, of very low cost, and easily available, efficient, more efficient and reliability improvements. Identification of sites is very easy, because on every shore you can put in each device and to produce energy. Better understanding of impacts of marine life and shoreline, and weather effects over the life of the facility, and the ability to survive in the marine environment. So you can, even with setting these devices, you can even look into the ocean, and you can have the information of the ocean and the biotic animals, what they live there. And that's it. Thanks. Thank you, Dr. Roby.
Any questions? Oh, questions. I have one. How deep is the equipment should go? How deep down in the ocean?
As you go deeper into the ocean level, the force of the tidal waves increases when compared to the surface. So, as much deep as you go, there's a chance of increasing your production. But there is also a problem of silt with it. So, that's another problem.
Probably the deeper you go, the cost will be increasing. So at 10 meters or 20 meters, the cost is more lesser. Yes.
Very good. Yes, question.
Considering the deeper you go, you wouldn't necessarily be dealing with waves then, right? You'd be dealing with streams, like the jet, currents.
There are different type of devices. Few devices which will go with the tidal waves, and few which you go with the streams and all.
Okay. So it's two different devices compared to either.
Many devices that can be.
It's waves versus current.
Yes.
Okay.
Any more?
More questions. The hydropower in a river would go in typically a river stream and then goes to pipes or tubes, big ones, and be directed to turbines. So here you're putting the turbines also in the open water. I wouldn't say open air, open water. So and the wave and the currents would hit from wherever.
Which will rotate the turbine.
Okay. Very good. Very good. Any other questions? So would you please give them? Thank you very much. Excellent.